body was there by we are making biomass. Okay. So environment friendly charge materials is like production of clean and green DRI. I will put the concept. Green DRI and clean DRI means less units. Okay. So before that, like metallic charge material, what is the requirement or what is the benefit? Here is the lower coated glass furnace. Sometimes for increasing the production, I was at that time when I was in industry that time, sometimes small diamond charging was to maintain the product, means production rate. Suppose the downstream process requires some extra liquid metal, then how to increase the productivity? Although sometimes it is not economical also, but sometimes it requires, like giving charge DRI somehow. Suddenly you can get some amount of more liquid metals. So metallic charge materials actually lower the coated, high productivity in glass furnace, and enabling these charge materials is pigmentals for basic or oxygen content. Benefits to reduce pellets of water chemical composition is good. Nowadays the pellets are producing for DRI. Not only the reason for using this DRI pellets in DRI, like utilization of fines. Initially you have a lot of fines, you cannot charge in cylinder making. Nowadays a lot of technologies are there, you can use the fines also in cylinder. Pre-agglomeration followed by cylinder making, all the techniques are there. But generally we consider the coarse particles, it will go to the cylinder making, finer particles it will go to the pellet. This was our earlier concept. To utilize these fines, it requires to make the pellet. But nowadays you are producing pellets from, although it is possible to get lamp or the injection is crushing it, after that you beneficiate it, and then you are traveling raw materials. In these raw materials it will be used as EAF or EAF, reduce it to EAF. So the benefit of normal sponge iron means from the lamp or and sponge iron from pellets, you can get the benefit like chemical composition you can alter. Like suppose your pellet you will charge in blast furnace. Your aim is to produce foundry grade iron. Suppose it requires some amount of money. So if you use pellet, you can introduce some basic oxides also you can incorporate in case of in pellets. Okay. So pellets composition you can alter because it is called the tailor-made product. Tailor-made product. Lamp or the basic differences like cinder pellets are the tailor-made product. Fabricated, synthesized. You can fabricate at so this is the chemical composition to got waste harmonious materials would be used for the reaction. Any waste materials which is not directly and negatively used in the glass furnace, you can incorporate it using the characterization property of reaction like sludge, like some carbon substances, etc. Disadvantage is poor weather resistant and less weight. This is the problem of the metallic charge. Poor weather resistance, you cannot keep like the sponge iron in this humid weather in open atmosphere. You cannot and also the strength point it is less because when it reduces what happens, the oxygen from the iron ore lattice it comes out. When it comes out, it forms the porosity, because initially some when the structure, solid structure, if you take away the oxygen, when this porosity means when this vacant porosity will actually porosity. So this is that they for us that means for us spongy nature, that is spongy. So it is less strain. Okay, I am not going to again on. So this finds, if you see, 17 data, it is it will do more now. But if you see less than 10 ml size, then it will be more than 65%. We generally call less than 10 ml size, then iron ore is waste. We mean fines. And if you see this huge amount of fines, the main reason for this huge amount of fines is like softer nature. Iron ore, Indian iron ore, typically softer in nature. Therefore, when it mines, what happens? It generates a lot of mines, which you cannot directly use on a chart materials. And if you see the effective utilization of mineral resource, iron ore mines needs to be utilized. It is our mineral conservation and waste utilization points from the government. And we can use fluid like sinter pellets. It is the coarser one. You can go for the intermediate. It is the finer one. It is the intermediate. I will discuss one. If it is intermediate one, what is it? If it is intermediate one, it is not fines. It is not coarser. In between. Below 10 mm. All are below 10 mm.
When you go,
Like 3 mm to 8 mm, 10 mm, suppose you can start in single. Right? Then less than 1 mm, you can go for the pallet. If it is 1 to 3 mm, what will happen?
nowadays we charge it
And now you can charge like pre-accumulation nodular the drum. No? Denodulize the drum. You can use it. But suppose, forget about it, in between this fraction. That is the process, like you know about vomit process and phosphate process. Right, discuss this one. So one vomit process and phosphate process. One it will be used for fines one, fines one. To get pellets and then you will use pellets. One it will be intermediate. Like earlier what happened? If you are constantly less than 3 mm size iron ore, you cannot use in the same time due to the shortcut code. Okay. Then this process was general actually. This replaces the intermediate particles. So in case of sinter, problem is like uneven shape, handling is the problem, reducing the less comfort for pellets, and less AC content because it is considered sinter is considered as the sweeper, means sweeper. I cannot say that as sweeper. When I visited Tata for project proposal, I told he I had some proposal regarding this type of pellets. So you can prepare pellets and you can use it. Then they told, but sinter is waste. Why? It has been less heavy content, less reducibility और अरे नहीं हमारा ब्लेंड जितना वेस्ट है मैं उसमें डाउन कर देता हूँ. In this way, sinter maximally actually works. Like you can utilize the waste material, like iron generators, some carbon content, you can charge line there, waste fines, you can charge. In this way, actually, if you see the overall electric content, why what is the disadvantages of this flux pallets? We are making flux sheet trap, okay? But what is the problem of making flux pallets? Utilization of this flux is the problem. But if you see, making when the preparation is somehow tricky. You see here the different temperatures, apparent density, and you can see this is the compressive strength. Okay, you can use the resistivity. Okay, and this is the shutter and tumbler. You can use the actually
The city is from 0 to 2.
you want
Yes, sir, is 0 to 2. You can make.
this is like discussing only the flux pallets now. Then we will discuss with the super flux pallets. So what is the basic
Super flux is a high amount of flux in that.
when density will be more than 2
Oh, was there a study of the CCS? CCS of this
volt
project?
strength, volt traffic.
No. If there data here, CCS.
CCS, yes.
Yes.
Because CCS is more relevant data than
CCS, compressive. For making pellets is slightly different and difficult. Otherwise, you can use this flux pellet. What is the major problem is like when you want to prepare the pellets, like if you add line heights, iron ore, and if you want to go for preparation of the pellets, it will be difficult.
Sticking.
Why?
Sticking. Add water.
Before that,
Add water to make it a lump. It can be dried in ball mill.
I will give you line order. I will give you iron ore, bentonite,
Bentonite.
water, and I will tell you the make pallet. Can you make pallet? Huh? Can you make pallet?
Yes.
How can you make pallet?
Normal. Gate pallet is not so much difficult, but the properties with high temperature is
Initially, green pallet formation will be difficult.
we need temperature, otherwise we don't
When you mix that one and you go for pelletization, what will happen? CO will produce calcium hydroxide. It will generate a lot of heat. Then pellets will break.
so why to use lime instead of
Then another routes are there also. Like you cannot make the pellet with adding limestone, lime fines, iron ore fines, bentonite and water. These are not. We have tried it all.
because lime contact with moisture
It will generate a vapor. H2 generate formation will be there. Steam vapor pressure, it will break the pellets. Therefore, the green condition, if you want to make the pellet, you have to prepare the slake line. Means calcium hydroxide formation is required first. After that, one is slaking here. After that, you can add that line and you can make the pellet. Then this slake calcium hydroxide will act as the binder also. It will bind. Number one problem. It can be solved. Number two problem will be when you go for the higher line content. These pellets will be utilized in like suppose block pellets because we are discussing the flux pellet, not super pellet. Then when you after making the pellets, what will happen? It requires drying. It requires your hardening. Then what will happen? Drying will not any problem. But when you go for the hardening of person, at a time particular temperature, there are 75 degrees centigrade temperature, the dissociation of moisture will take place. Calcium hydroxide bonding will dissociate. Then what will form? Again it will form CO. Okay? Then if you keep this pellets in open atmosphere, what will happen? It will again take the moisture. Again it will expand. And when it will expand, it will break the pellets. It is therefore it is hygroscopic in nature. This pellets. Then how to tackle this problem? Free line should not be there. It will see presence of free line actually creates the pellet hygroscopic. Then you have to make the pellets non hygroscopic. so that there should not be any free line present on the surface. Huh? If you can restrict the free line formation of the surface, then you can restrict prevent that breaking of the pellet. And yes, one mechanism is there. Like if you increase the temperature and if this line will react with some other elements so that it will be compound, not a free line. But CO will not be present like CO. It will be like CO dot SI or a would be in this way. Okay? Then you can do it. How much temperature is required? If you see the Carnot diagram, this one. This is the liquid phase. Okay? It means this is the slag zone. Huh?
You can have 1200 degrees Celsius.
Yes. Look.
Because that is the composition of the primary slag. Composition of the primary slag inside blast furnace.
It is the critical temperature where you can heat. That means if you can heat at 1200 degrees centigrade temperature, yes, it will form that compound. But we have tried a lot. Like we have the pellets for 1100 degree 11, 25 11. If this way we gradually increase, what we observe, like when we cross the 1200 degree centigrade temperature, then another problem is arise. What is this problem? No, the problem is like when you increase the lime content, it will increase the and it will form a fluid slag. If there is no line, the slag will be the viscous in nature. If there is some line, slag will be fluid in nature. Then what will happen? This slag will try to come out from the pellet. Then what will happen? Suppose your hardening mechanism.
The volume expansion will take place in a much higher region in the blast furnace.
When you go for you think about the practical, like in plain furnace you will harden. Suppose in a clean furnace you will harden. Then what will happen?
You are talking about before putting into the furnace. You are talking about that.
Hardening portion. I am now in the hardening portion. Okay. Then when these pellets will move inside the ring plane and liquid slag, it will try to come out from the surface. And this liquid slag is sticky in nature. One liquid slag from one pellet, it will come out, another pellet it will come out, it will stick. Then two pellets will stick, three pellets will stick, four pellets will stick. In this way, you will get a agglomerated product, not pellets. Then what to do? We have to think in which temperature there will be no free line, as well as there will be no slag formation. It is liquid slag formation. Slag will be there, otherwise it will not combine. Slag should be there, viscous slag should be there, but you have to critically handle that higher temperature so that it will not come out. Then we have done this experiment. You can see 2, 4, 6, 8. This way. We have just before that but I discussed the first the advantages. It can be used as a EAF, lower operating blast furnace, lower finishing electrical furnace, because if you can incorporate line here, then the addition of line fines it will be less, regeneration will be less, and line fines would be utilized, waste fines also can be utilized. But major findings from our study is lower stage the pellets failure at lower temperature current is the presence of the free line, and higher stage but lower porosity and sealing property if we have fired at 12 or more than 1200 degrees centigrade temperature. Then we have determined how much necessity we can do. This is the slag zone, liquid zone. Okay. So this is the superflux pellet. Okay. This is the exciting analysis of the
Flux pellet will be advantageous only when we need a higher velocity.
Huh?
Flux pellet are advantageous when we need a higher velocity.
And need a higher density. Generally for charging in electrical
Electrical.
or suppose we basic oxygen furnace. What is the charge? One is the metal charge, which is iron, the scrap or metal or something. Another is line. If you want to avoid the line charge due to this environmental problem, line, then this type of problem will be less. And another advantages of this high risk pellets is like dissolution property. Like generally what happens, if you chart line, what is the dissolution is faster, fast requirement, then if you go for the dissolution reaction, all the things.
higher cooperative requirement.
I am not.
No,
In
no,
that case also,
that
if
is
we
estimate.
if we
I
add that
am
like
steel making now.
Steel making.
And when I am discuss the
So line will you see
if your steel making operation requires line fines, okay, and line fines you know the problem hydrogen nature, sometimes it explodes also due to the moisture absorption. So if you want to avoid that line content, so you can do incorporation of line in some material so that it will not be a hygroscopic. So you can incorporate in the metallic charges as a line, fast pellets, super fast pellets. Then super fast pellets ka I discuss the problem. Then you have to optimize the parameter so that your charge materials will be metallic in nature, line will be incorporated, and there will be no steel property. There will be no hygroscopic nature. Then we have done a lot of experiments and we have determined that optimum temperature is like 1180 degrees centigrade. If you straight away go for the firing at 1180 degrees centigrade temperature, yes, you will. But problem is, like industry cannot fix it like your plane it is 1180. No. You have to give some ranges, like 10 degrees, 15 degrees. So you cannot fix like in our laboratory experiment. 480 means yes, it will maintain 480. This is not possible for normal furnace. It is possible for electric furnace. Then in that condition, what will happen? The metallic charged materials where the line is incorporated and line is not as a free material, and it will dissolve very faster. If it dissolves very faster, what will happen? The slag formation is very faster, and the desulfurization rate will be very quick. Because initially what happens? You charge the line. It takes a little time fast because time, 20% of line hard. You will have. If it will take time to dissolve, after that it will do the reaction like desulfurization. Yes. So then the impedance removal will be faster for this type of analysis. Okay. But precisely you have to control it. Depending on the different temperature, you have different density requirements. You have to replicate this type of pellets, and you have to choose the optimum temperature to this one, so that my plane will not have any clinker formation. Exactly, you know, clinker formation. So if slag will come out, it will form a clinker. So it will form initially a spread layer inside the clean, and after that layer will move in this way. So then this is the you can see here. This is the crushing step. Okay. You can see drastically it is reduced because when up to which if the free lines are there is no slag bonding, the strength is less. When it started production of this compound, drastically you can see the increment of the strength, CCS, old products.
So the necessity is from 0 to 8 or 0.2 to
2 to 8. 2 to 8, how you can handle this 8 necessity is very difficult.
8 is too much.
Too much. This is for
No,
experimental
this is not for glass furnace.
Not for blast furnace. This is not for blast furnace. This is for you can utilize electric arc furnace. But for our experimental purpose, I have to take one long range. Yes, how much it is possible? This is it. And obviously, if the strength is increased, what will happen? Obviously, it is the porosity portion it will decrease because the slag formation is there. It will block the some porosity, internal porosity, etc. And again, see the other obviously this increase, porosity decrease, etc. Then, in composite pellets, as the materials is reductant is incorporated inside the pellet, when you fire it, what will happen? It will give the strain as well as the reduction. But this strain is not so much high as strain is achieved during the firing of normal conventional. So when the reduction will take place, it will produce the porosities and it will give the risk. Then the benefit of this composite pellets is like this is directly metallic type. Single heating operation for hardening and reduction, no separate heating operation. Utilization of waste fines for the as a reductant. But the disadvantage is prone to reoxidation. This is composite pellet means one type of DRI. DRI is also hydrophilic in nature. It will also absorb the moisture. So prone to reoxidation, less strain, storage and transportation is a problem. Okay. And incomplete utilization of reductant. The last point I want to say, incomplete utilization of reductant. It means, suppose this is your pellet. It contains 10 gram Epicure. Okay. If you calculate to reduce 100% 10 gram Epicure, suppose X gram of carbon is required. So is it possible to reduce 100% it? And 100% reduction is not possible obviously. As you know, 100% for 100% reduction of 10 gram Epicure, suppose it requires X gram. If you put X gram reductant, it will reduce 100%. Because why it will not reduce 100%?
Because it's the reaction will be what? It's a solid. Both material will be solid. So how can the process will never be efficient. That process.
Any other comments?
Can you repeat the question again?
Suppose this is pellets. Okay. 10 gram Epicure is there. Okay. And to reduce this 10 gram Epicure, X gram carbon is required. I incorporated extra gram carbon and I make the composite pellets and I reduce it.
A layer will be formed over it. So over the surface, a layer will be formed. That will prevent further reacting with the.
And this will be for the gas diffusion model. But composite pellet means in situ reaction will be there. In situ reaction. In situ reaction, although in situ reaction will be there, but incomplete utilization of the carbon reductant. Because what happened? Carbon will react first to form carbon dioxide. The carbon dioxide acidity you always will keep inside the pellet. It will try to come out. Escape out. So suppose 30% carbon is utilized. Sorry, 40-60, then there is 60-20% carbon is utilized. Remaining 30-40%, what will happen if you form the CO2 and it will come out? You cannot avoid that. It means it always utilizes more amount, it requires more amount of carbonaceous material than it is compared to its original requirement. Then always you require 30-40% more reduction. Number two, when due to the reaction, what will happen? CO2, SO2, all gases will come out, and these all gases will come out and it will go to the environment. It means the environment will be polluted. It will create the pollution. It means the composite pellet, along with this type of disadvantages, you will get the incomplete utilization of the reductant and it will create the pollution. All the process will create the pollution. But if we consider this one and the environmental consideration, then this type of concept. What is this concept? Concept is, you can see this inside is like iron ore line. It is called the core of the pellet. Core. And another one is called the coating of the pellet. When we file the patent, sent me 4-5 patents regarding the composite pellets. And this type of composite pellets are already 3 to 4 types. A lot of composite pellets are there. Means rare pellets. They are asking about the rare pellets. And sometimes to enhance the properties, surface property also. I visited South Korea. One student, researcher, presenting his works like coating of iron ore pellets with carbon. Actually, I think he was a student, or actually the Chinese, they do not understand English. I'm asking why, what is your aim of putting carbon at outer side? It is for making the metal inside material so that you can melt it in induction. After that, he came back and discussed what was their question. Sir, this is for you. I asked to my supervisor. So, a lot of coating pellets are developed, like not only by coating with iron, coating with carbon, sometimes coating with lime. Okay, sometimes lime incorporated inside the core, sometimes lime carbon incorporated in the inside of the pellet. So here the coating mechanism is like iron ore coating. So what is the benefit? When you go for the hardening operation, then you can see here this is the conventional composite pellet. Ore is conventional composite pellet. But you are providing an insulating layer. Iron ore fines there will accept the insulating layer. What is the advantage of this insulating layer? Number one, it will effectively utilize the carbon content because it is the insulator. Okay, it will prevent the leachy escape of CO2. Now, it means the stoichiometric carbon requirement will be less. Number two, it will act as an insulator. Therefore, it will prevent the means as composite practice pyrophilic nature. It will prevent because it will be the weather resistant. Okay. But the disadvantage if you see, like this coating layer, although it will not reduce 100% because this surface area, if you see, it will oxides. Sometimes it converted up to a few. Generally, a few over there is the observed this layer, over there. Then like point. How it's pitching this person. Then what will happen when you reduce it? Then you will get reduced iron in the core. Okay, and one insulating layer which is semi-reduced, partially reduced coating layer. But actually this work was started in a Guruji, Professor R.C. Gupta. I think Professor is familiar, he is student of Professor R.C. Gupta. So what happened? This trial was done in Usam at that time. But the problem is the formation of this cavity formation will be there. Why? Because when it reduces, it sinks, it will sink, but there is no carbon here, it will not sink so much. There will be a difference between coating and core layer. I will show you the real picture of the pellet. Okay. Then just for your understanding, like if you compare BR and CPR, it is called the CPR pattern, composite pre-reduced pattern. Okay. It is composite, but it is pre-reduced. So if you see BR and CPR, if you compare it, mechanism is like in case of conventional they are making waste fine, pelletized, firing in oxide environment if you fire it, oxide iron will form and it will transport to DRI plant or pellet firing, then DRI will produce. Two-step process. Here you can see pelletize, pellet fire and metallic iron will be get. Okay. So advantage wise, lower coke rate and high productivity, low lower sulfur content. Then I thought if that guy is listen my presentation clearly, you are telling, but because before that I did not discuss regarding the sulfur content, SO2 gas content, but that guy, he asked me the question, you told it is the encased metal charge material which will prevent all the gaseous emission. Simultaneously sulfur emission will be prevented, yes. Then sulfur should be high, yes. Then what you are talking here is that lower sulfur content in the bottom. Because your charge material content already is high sulfur. Actually, this is not for that one. Actually, this is due to the lower CO2 requirement. Therefore, ultimately, the lower sulfur content. It's clear. And operational benefit is like storage is easy. In storage machines, you will not have parabolic nature, therefore you can store easily. Better charge distribution, size is typically more. Better furnace operation as the interparticle space is high, permeability weight is high. Your sphere will give you the maximum value. Many safeties, changing the orientation, the permeability of the weight will differ. Triangle low, square low, point is high, safe. Only the sphere, if you change the orientation also, it could means the weight permeability is not altered. This is the benefit of alloy. Because as a iron rod, as a DGR, from the top, as a sometimes it may be there, sometimes it may be here, sometimes the permeability will increase, sometimes permeability may decrease. But in case of pallet, it will not increase the permeability because it stays very close. And if your pallet size is close size like 15 to 16 mm, 48 to 16 mm, then permeability is maximum. It is not order. And better furnace operation, commercially you see lower hot metal cost, higher metal capacity, flexibility, lower capital needed for the enhancing the blast furnace capacity, like I discussed, we sometimes buy that materials to improve the production. Then this is the comparison of CPR pallet and DRI. If you see alumina CPR ratio is less here. Metallization percentage sometimes very less, but it is why it is low as compared to the DRI. Metallization is low as compared to the DRI.
Is it a coating written on the top?
Coating is partially reduced. It means some amount of iron ore which is applied for coating, it is reduced partially, like up to XDO. Sometimes FEO, maximum it will be the FEO. But FEO is very difficult because at that time the value was analytical is high. So therefore the metallization is, but another disadvantage is like crushing speed is less, which I discussed regarding the formation of the
But that is
then we discuss, this is actually our one real study practice. You can see the core and the coating. Okay, then actually if you see why it is lower strength, initially this is called the load displacement graph. If you apply the load, initially it will go, again it will lower down means due to the breaking of the coating layer. Again, when you will apply the load, again it will give you the strain. But this strain is called the core strain and this is called the coating strain. Always coating strain is less than the core strain, therefore it creates the problem. Okay. Then what will happen? If the coating strain is very less, then when you charge inside the blast furnace, what will happen? Overlying button materials load sometimes it will break the coating. Therefore, this trial of Usama was great.
actually the CCS is very low. It's 120. 120 is not suitable for blast furnace.
Therefore, we at that time thought how to increase this coating layer. Then our concept was come. Suppose this is the unreduced condition, this is the reduced condition. Then sir told, the sir told, कि अरुण एक arrangement करो It means coating layers should be supported by some grades so that the coating layer strength will increase. Then we have tried a lot to increase that. Then we incorporate something along with the basicity, because this is still now we patent just a few years submitted. So then we incorporated here in wood, and after that we applied the coating, and we got the strength of 295 kg, which is acceptable. Okay. So this is the first year. Yeah. This is the different property. You can see the weather is. This is actually palette of reduction. We take the cross section. If we go for high temperature, if we go for high basicity, what is the effect? If you see, if you go for the high basicity and temperature, what will happen? As I discussed, the lower melting edges will generate. Why is lower melting edges? Lower melting edges is the slag. Slag is a mixture of like CO is there, L12 is there, but at that time another component will also join here. It is called the FEO. When you do the reduction, what will happen? FEO will try to join in this system. If the FEO will dissolve in the system, what will happen? It will. This is the bottom portion of the pellets. Pellets was in this position. At the bottom portion, we observe the materials is eroded, and it produces the slag. Because in stationary condition, stationary condition, FeO content, it will gradually dissolve in the slag, then it puncture or happen at the top. Okay. Therefore, higher basicity, then we propose another method. You can prepare this one. This was the optimum condition. You can see this one the lower temperature condition. Optimum condition. This is the higher basicity and temperature. Then we propose one mechanism like if the pellet is not stationary during heating, if the pellet is not stationary, if it is moving, it means if it rotates, then what will happen? It will not function. It will not erode. The slag will form, but slag will form a coating throughout the cavity, and it will form the supporting layer which is required, like as I proposed here. This slag, it will form, and it will give a support to the coating effectively. What will happen? Coating will not break. It will break in a single load. It means the load displacement part will be in this way, straight way in this way, after that it will go. This is our end. Then we have a 295 kg per pellet in this. And this is the stability. Stability experiments actually you can see the paper. If you increase the temperature, pellets will be unstable. It is 1 mm coating thickness. It means it will be less stable. 1 mm coating thickness will be eroded fast. 2 mm. Sustain some of 3 mm you can see. It will sustain up to 3 basically. But when you use the flow height, it will not stable. Therefore, you have to choose this parameters. Your requirement of basicity, how much? Then accordingly you have to hire it and you can take it.
The 3 mm is what basicity?
3 mm, if you see here 4 and 5 basicity, the pellets and hardened at 1200, not basicity is not only the pellet, hardening temperature is also a factor. Okay. Because we prefer this one higher because it will give you the more metallization in shorter period of time. But at the same time, if you think that coating thickness is high, then it can sustain. But coating thickness is another drawbacks. only stable in this range. It means 1000 degrees centigrade per 10 if you reduce it up to 5 degrees you can go. But at that time to achieve the required reduction you have to increase the time of reduction.
So the increased Fe content in composite pellet is due to lime addition. As compared to iron ore pellets, the Fe content is around 62 degrees. And in composite pellets, the Fe content is 72 to 80%, I guess. That's slightly lower.
80 content.
Fe percentage in the composite pellets was about 72 to 80%.
18 and total
Totally.
Fe content.
So it is additional Fe is from lime.
No. Fe total means after reduction only you get 70%, 80% metallization. But in case of Fe total, but if you see any other DRI, it will go up almost 80-85%. It is less due to the coating here.
टोटल एफी है
एफी का एस्टिमेट ले सकता है
उसका परसेंटेज कम हो रहा है.
ऑक्सीजन उसमें रहा है
Then the biomass in relation, this was up to that level, it was all experiment was with the third one. It's coal. Then biomass, I think 3 days you know why biomass is carbon neutral. Okay, lower cycle, intensive cycle, its lifespan is lower. Okay, so many of biomass is renewable. Wood char is the best carbon with the best impurities, and it is ideal for the tropical areas like India also. Ideal for storage for solar energy as well as that for shorter duration you can renew it, and renew it. Okay, and the limitation is land, land, water, labor, energy, forestry mechanization, and utility. So, coke versus wood char, you will know just as you see the wood char and coke, you can see the gas analysis less. So, increased content is this. Okay, different types of biomass and different
Sir, previous slide.
one back.
So volatile matter in charcoal is 25%. Wood char, the first group, it is 25% VM there.
Yes, in case of biomass, wood char or biomass, if volatility is high, don't think until the biochar which will be produced at 800 degrees centigrade, 1000 degrees centigrade, all volatility will come. We have done here experiment. This year's requirement is, and as is very less, volatility is very high, moisture is very high. It depends upon how much temperature you do this calculation. If you do the calculation 600 degrees centigrade temperature, 800
So it will be very harmful for all the suction apparatus.
and volatiles. Therefore,
It will
if
corrode
you
our
want
whole
using
system.
steam technique,
It will
what will
corrode
happen?
the ESP or
Yes,
ESP inlet. Yeah.
Number two, it broadens the peak. Peak broadening occurs. Therefore, it increases the property of steam. Therefore, you can utilize some of percentage. You can utilize some.
So it is not advisable to use biomass in-house at this point.
Then, like, if you see side fraction of the iron, the finite particles goes with the pellet. Course are blast furnace, although nowadays it's not good. And intermediate like this zone, you will go therefore the blast furnace. Then what will happen? You have to make DRI. Okay. It may be from coarse particles or it may be from finer order. So then coarse particles directly goes to DRI, intermediate particles who generally still now we are forcefully go for the pelletization. Some amount we are using the sinter melting, but general case we have to go for the pelletization. Okay. And in future when blast furnace will not be there, then there will be no question of sinter melting. Okay. And fines will go for the
So
pelletization.
intermediate is from 1 mm to 5 mm. Intermediate portion is from 1 mm to 5 mm.
Less than the
Less than the-
intermediate having boundary wide area, because when sinter we are assuming in a position of when there will be no blast furnace. Okay. Then this will be intermediate portion also. Sinter particle size will be also under the intermediate particles, na? Agree? When there will be no blast furnace, there will be no
Sinter balance.
If there is no sinter, then all particles will be intermediate portion. Then you can see this one is the other methods. Again, one is like forcefully pellet making. You have to use it, and you know the grinding energy is high standard. Grinding energy is very hard. Therefore, and at disadvantages, externally it generates pollution, it requires manpower also. Then suppose these are this area, intermediate area. Therefore, I have given 12 mm up to 12 mm, which can be utilized as a sinter, but we are assuming that in this zone there will be no sinter requirement. Okay. Then this is my answer. Is there any stable established method? Yes. Established methods are there. Okay. Coal base mineralizing process. So comet process, direct reduction process with a sandwich layer. Sorry, I don't know. In this comet process, what happened? Comet process is a direct reaction process. Sandwich layer will be there. Generally, it operates in RH. RH is slightly like concept of RH, like where the hardness is hard is rotating, but the materials are stationary. Therefore, this is the material. Then this RH furnace, it goes up 1300, sometimes 1400 degrees. And benefit is like because this DRI you can prepare, and nowadays you can also. Okay. So this process actually helps for sticking out from the pelletization as well as the grinding process. Okay. Energy conservation as it avoid grinding operation. But conventional comet is the oldest metallization process. ये स्कूल में बात करेगा, ठीक है? घुमला होगा ना काजू कर दो। अभी तुम्हारे नहीं देखी वो चीज़, अभी वो चीज़। So disadvantage is like fuel fossil fuel. Coal based metallization is fossil fuel. At high temperature, residues of the coal and the binders are trapped. Therefore, during starting of this I discussed green by using biomass, but it should be clean also. Clean means less impure air. But here, high temperature, what happens? The ash content, if it is actually trapped within this layer, then the DRI which is produced, it will be the impure one. Okay? It creates the environmental pollution and reduces the reduction environment. So, site selection of this iron ore, you see the next one, it is the pellet. It will be the concern, because two portion will be concern, higher percent, intermediate percent, it can go for the comet, and this fine percent it will be valuable at that time. utilization of the kinds in future would be DRI in form of composite pellets. Then the composite pellets are made with iron ore and reductants. The prototype technology is called the fast made process. Okay? The fast made process, what happens? It is actually which I discussed here. Before discussing the composite pellet, fast made process is the composite pellet. Okay? Preparation of the metal charge material by the use of composite in RH furnace. Here also you can see the procedure use high temperature resistance of the coal and the binder and in there create the environmental pollution, reduction environmental harm, all these type of programs are. Then in which direction we are working now? Modified area with the biomass. So just we have something with the one project, one area, and our is also one area. So here we replace the biomass layer, whole layer by biomass, sanding the biomass. Then we expected, because it is already expected that we can produce the green already is green, so green area also. So we named that shape bio-made process, which can be the bio-made process, and bio-factory process, which can be the conventional farming. Okay. This is one study in this slide on student. It is he has taken non-cooking as a reference reductant as well as the Surya Robusta biomass. Surya Robusta is salt because this is area salt. The Surya Robusta is major species. Then what he has done, like sandwich layer here, and this is the you can see the reduction time at different temperature. It means particular and different reduction time. Carbon utilization, this is the carbon utilization. How much carbon is utilized? 46%, which increases up to 89%. As entrapment, you can see here, as entrapment is increasing, should be increased, but this was done by BTEC. Something maybe some error may come, but as entrapment it is increasing. Okay, percentage of reduction you can see up to 96% reduction. Okay. In case of biomass, almost similar but higher degree of reduction. Okay, and here the beauty almost zero as something suppose 1%, 2% maybe enter, but if the sample size is less, you cannot identify the how much materials is inside the balance. Because some interaction is there, we can be shown in next slide. Like the DRI, you can see it is the cold range. Interaction is there. Okay, and here you can see FeO.Si is AC there. It means this FeO.Si2 is made from the iron ore itself, because iron ore contains FeO as well as Si2. But here you can see here another peak is there, SiO2 and FeO.Si2. It means these two peaks it was due to the entrapment of the. And actually I missed one slide. I tried to call my MTech student to take this what clean stage. We have melted iron with this biomass based DRI as well as coal based DRI, both. And he has got an excellent result, like the impurities present inside the steel also decreases in case of biomass reduced DRI. If you advantage is 0.5, but the analysis of the steel which is produced from the biomass reduced DRI, it is 0.18. Sulfur is also low, phosphorus is also low. You can see heavy metallization. Sorry, this is actually an analysis of DRI. But I talked about the steel also. We have done the making of steel also with the biomass reduced DRI and cold reduced DRI. You can see that the DRI which is produced, it contains less carbon, less sulfur, less phosphorus, and here you will see slightly, you can see the Fe total slightly is more in case of cold base. But if you see another Fe oxide here, it is Fe oxide, it is 13.96, it is 19.69. SiO2 content, it is actually the gangue materials, it is slightly less as compared to the coal, and Al2 is also gangue materials. Therefore, the DRI which is produced, it is quite clean DRI as compared to the DRI produced in the cold base.
So this DRI is a feed for EAF, right? So
We
the
have one for the
sulfur content is quite high, 0.260.
No. This is not. This is the DRI. This is DRI. Analysis of DRI. And I missed the analysis of steel which we produced by this two types of DRI.
So this DRI will go to EAF.
It will go to EAF, but before charging the EAF, this is the composition of DRI, which is produced by reduced with biomass and reduced with coal.
So this is output of DRI.
Is it analysis is similar to iron that you produce hot metal?
No. You can see this one is this is the analysis of that DRI itself. Inside the DRI, how much carbon is there, how much sulfur is there, how much phosphorus is there. And inside this DRI having the 78% metallization, Fe total inside the DRI is 82.95%, Fe in oxide form it is 13.96%, silica present in the DRI as it is entrapped.
Okay.
Inside the DRI silica should not be there, but it is entrapped condition. SiO2 present is 12.07, Al2 content is 0.8. Okay.
So what is the time of reduction? This one, biomass reduction.
This is 1200 degree centigrade temperature. I think it is you want to degrees. Holding time. Holding time means after achieving the temperature 1200 degree centigrade temperature, hold for 100 degree for completion of the reaction. After that you take out the sample.
So it will form by a nugget or just the DRI? Form a nugget kind of thing or?
This is DRI means pellets.
Correct.
Sir, you have that microstructure. Maybe some cementite should be evidence, I guess.
Yes. FTC. Yes. Then so after
Tea break.
very still using hydrogen and oxygen. Because in place of hydrogen, you are trying to reduce by ammonia also. So I will discuss regarding some benefits, advantages, and some disadvantages of the ammonia use. Okay. So I think we should skip those slides. Sorry. one is the promote the sustainable development. It means carbon neutrality one, but finally we have to go for the sustainable development of the. Okay. Therefore, people start thinking about the green steel, although it is still now first year. Okay. So why we should produce steel? We should produce the steel with a lower emission, carbon footprint should be lower one. Number two is toward the sustainability I am talking. Lower energy utilization, less byproduct generation, and higher efficiency. Okay. If we only consider this one, lower emission, so this is the CO2 emission produced from the fossil fuels and industry in the statistics 2022 in turn. US, I think Fox have already discussed this one. US having the highest one. In India, you can see 59% for the entire. So decarbonization in iron and steel industry, this is required because 7 to 9% is varying. Sometimes someone will tell you 7%, sometimes someone will tell you the 9%. So average 7 to 9% of the global CO2 emission. And why it is important for India? Because our pathway to reduce emission is, if you see first one is the carbon capture. You know, I think I have some slides here. What is the roadmap of our India, government of India?
2017.
2070 is the structure, but stepwise. You know, I was saying 30,
By 2030
below 2.
50,
50.
and 70. So 30, 50 and 70, I think like that slide.
30, 40, 70.
No. That's in smelting reduction, I think. So stepwise means initially up to 30, if you see, government of India has no plan of hydrogen. Okay. So mainly they will focus regarding the energy optimization, use of optimized energy, lower energy consumption, efficient technology, etc. So that overall CO2 emission will decrease. Number two is up to 50. 50 means then government is trying to develop some technologies here. You know, government is doing some joint proposal with other countries like Australia, UK, okay, to indigenize some technologies which will be applicable for CCU, CCS. Another thing is hydrogen production, obviously the green hydrogen production, and that all other green steel making technologies like DRI will be our first preference because we are in that we are the largest producer of DRI in the world. So stepwise, I will show you in the next presentation how government of India is thinking. So India's pathway to one is the carbon capture, because existing system we cannot scrap it out. Because when we convert, we gradually shift from the conventional to the renewable one or the green one, then it will hamper the production. By tomorrow, if we take all blast furnaces, so it is not possible. So existing blast furnace system, how we can reduce the CO2 emission cost will be our aim. Then, as per our target to 2030, we should think about some CCUS technology also, because existing blast furnace, if it will run, CCUS technology and CCUS technology should be implemented, or it should be a strong technology If the energy consumption is there, obviously the CO2 emission increases. Carbon free fuel and that. You can see this one is the hard one. Okay. Hard. Initially, obviously, the carbon capture is outside. And as I discussed, we cannot scrap it out in blast furnace. Why do it? And this blast furnace is a reactor. This beautiful reactor. You know the efficiency of the blast furnace is very high. Energy efficiency is very high. Production rate is very high. Okay. And you know the still now the iron making by the blast furnace is highest. Okay. Then you know this one is like carbon monoxide and SO3 which will produce the CO2 and O3. Then if you sorry this one if we replace this one CO by hydrogen, then it will be the product will be the environment friendly. So before going to the deep like what are the advantages, disadvantages and challenges when we use carbon and when we use hydrogen? It is cost effectiveness. Because this is cost effective one. Versatility. You can use but produce pig iron, not metal DRI form. Scalability. Carbon used furnace will be more scalable. Easily scalable. Hydrogen reduced to discuss. Steel now is not so much scalable. Smaller scale production facilities still now is developed. It is not pigments, it is not still now the mature one, okay, but it is the mature one. Sustainability point of view, if you see, using biochar renewable source instead of biofuels. Disadvantages is, you know, the CO2 emission is a disadvantage, limited availability is not renewable one, and it affects due to the CO2 and waste generation obviously the slag and the silicon content. The slag one because when your DRI is more clean, the slag generation will be less. If your DRI is less clean, then slag generation will be less. Okay. Then ultimately
What is this biofuel you're talking about?
biofuel means any other like methanol, ethanol, fabricated fuel from biomass. Then not only this waste generation will contribute the it will create the problem of environment. Also it requires more energy for cleaning because if your charge materials are in high band content, slag generation will be high. And if we are talking about the blast furnace, it is 500 means whole system is required to remove the temperature. This slag is also required to heat at a liquid temperature so that you can separate. Because separation mechanism pyrometry, you have to reach, you have to enhance the temperature at the temperature so that the metal and slag means impurities and the metal both will be in a liquid phase, then it does. And hydrogen having this advantage is like at room temperature or slightly elevated temperature you can do the experiment. So then if you can steep it, then the product is hydrogen one, H2O. But this hydrogen having compared to the disadvantages of the carbon reduction, it will be the advantages of this hydrogen use. Like environmental benefits, less carbon emission, energy efficiency. Hydrogen has high energy content and can be produced from renewable sources. If it's like I can share one story like Brahmacharya, he is also guru of my guru. There, he is getting older, like he can tell him also. Like at that time when we work in YouTube, Stanford, no, biomass is now, yes, hydrogen is one reductant, but it is not still now mature, it is not proven, and a renewable source of energy, it is not applicable for steel making. Okay, but nowadays we are thinking about the steel making with that renewable energy.
It is the smartest thing to do.
Okay, means I am telling you about 2000. I joined 2009. At that time, so because people are thinking applying this renewable energy, as this renewable energy is not directly used for reduction purpose because it requires reductant. So why why not we will produce the reductant from the renewable energy source? They need to do that because earlier concept was renewable energy means from the renewable energy you will get electricity. But how will produce the steel? Means initially iron. Because iron, for reduction of iron, it requires some reductant. Not only electricity, you will reduce it. So, flexibility, any iron can be used if it is beneficiated. And cost saving, in this concept, cost saving, like long term, because the process is more energy efficient and if it is the renewable one, then in long term case, if you see establishment cost, if you ignore that one, then long term you will be then that cost will. Okay. But the challenge is high cost of producing hydrogen steel now. Development of efficient and reliable technology for reduction process. Due to high temperature, this can lead the issues of that equipments. Formation of water vapor, this is another problem. This can reduce the yield of the desired product, but this type of problem now is sorted out. Gradually sorted out. And hydrogen is available gas, it requires special handling here as well as storage. Therefore, a lot of research are going on for hydrogen storage. Means materials development or hydrogen, effective hydrogen storage. Okay. Then if you compare the byproduct and it is harmful, but it is not harmful. Now it is lower cost, but still now it is higher and it having the environmental effects, but less environmental effects. And the produced iron will be more regular in case of hydrogen use. This which I have taken from slide is very interesting. Why we are talking about the hydrogen? Yes, hydrogen can be used in any area, iron making, but why we emphasize more in DRI making or agri steel making? This is the answer. If you see the replacement potential in case of blast furnace, you can inject, but how much? 10%. It means replacement ratio is only 10% for blast furnace. This is very important. If you go for the smelting route, you can replace up to 30%. Okay. I think it was taken from Rabo. Okay. But in DRI production, you can replace up to 100%.
Coal.
Okay.
Coal replacement you are talking.
The replacement potential of means another fuel.
Fuel is a coal, na?
No, sir, hydrogen.
Fuel required for
You are replacing the coal with hydrogen, na?
and then you can only 10% fuel can replace.
In the blast furnace, you
Blast
can.
furnace. Which work is done by my
Yeah.
They are incorporating
Injecting the hydrogen.
hydrogen, but they can go up to 100% hydrogen. But in case of like your blast furnace, if you want to replace the fuels by hydrogen, up 10% you can.
No, that is correct. Say my fuel rate is around 530 kg. 10% is 53 kg.
53. 53 kg you can
High.
you can decrease up to this is up to level.
Maximum. Very important. See, the trickiest part in the blast furnace is coke itself is a column of support to the buttons. If there is no coke, where will you hold this material? practically impossible to convert iron ore or sinter or pellets to liquid metal.
I think that
It
figure
can be
is
impossible.
170
Therefore,
kg per ton of watt metal.
Huh?
That figure is 170 kg per ton of watt metal.
That is a minimum. Maybe we can think of 150 by doing lot many things. Below that you cannot do, because there must be a physical support to the button.
Similarly, the smelting reduction area, if you can replace up to 30%, but if you go here, which Brahmacharya and his group is working with, they are using natural gas, but they are introducing hydrogen. Then they can 100% replace at a time when the system is normalized, they can 100% replace the fuel by hydrogen. Therefore, people are interested in this DRI.
Yeah,
Okay. So this DRI would like, if you see first one is like hydrogen DRI, hydrogen reduced DRI, EAF group, iron ore, direct reduction furnace, reduction using the hydrogen, DRI will produce somehow, you will add some scrap, heat as required, then you go for electric arc furnace melting, and you can produce electricity. Second one is like hydrogen reduced DRI, smelter, UAF group, via the iron ore will go, DRI melting, after that it will go for the smelter, and then reciprocal furnace, and again liquid steel. Another one is fluid grade. Probably I am surprising, Chinese, they are working in this fluid grade. Yeah. They did not disclose the actual how they are doing. I asked a lot of questions, but they did not reply.
Actually, they were into low temperature LDR using hydrogen, like the high for sometimes.
Then another is hydrogen plasma smelting reaction. I have discussed in the last day regarding that one. So these are the different routes of.
So this equipment you have purchased here.
Every year. So if you see the CO2 emissions of EAF group and HDRIF group, which claimed by the grid, this CO2 is very less one. You can see 25. Then hydrogen in the DRI group, it is the general contact furnace group, hydrogen, they are telling me. Hydrogen DRI furnace, it can also be supplemented with natural gas as its ability is better. I think your plan is also similar type of reactor.
Yeah, actually we had the plan of getting natural gas. Suddenly GAIL has lifted its hand. He will not supply. Therefore we have to shift our focus to hydrogen.
This is only the reason.
Yeah, because they promised, we were waiting for the natural gas to come. Our plan was originally to take natural gas into blast furnace and DRI. All furnaces. All of a sudden they cut.
And this is the actually hydrogen, the fluidized grade. Two types there are one is the fluidized grade, followed by the briquettes, making, and then it starts to the electrical furnace. Okay. There are some problems like you cannot directly charge this fines. Fluidized grade means the product is the fine in nature, and this fine in nature materials you cannot charge in electrical furnace to get the more yield. Actually, this process you will get the more yield. And this is the electrical furnace, the other is the smelter and basic oxygen furnace. And smelter, basic oxygen furnace route, and fundamentals of this hydrogen plasma smelting is like people claim initially like in plasma smelting route, plasma is a generator of heat, means source of heat. Number one. Number two, hydrogen as a reductant to land. Then what is the difference between the reduction of normal hydrogen or DRI making, sponge minus HDRI, and the role of hydrogen in plasma state or I don't know In both cases, it will reduce to liquid iron, metallic iron. But the beauty of this plasma is, like it is excited phase. Plasma means it is not having the only hydrogen gas. It is the hydrogen species like hydrogen, ions, molecules, excited species also. Therefore, they are more reactive. And as the plasma generates a very high temperature, so conversion is very fast, very shorter period of time you will get the liquid metal. Okay, one beauty is there. Number two is like as it generates very high temperature, so the generated slag, it will be also a fluid in nature because high viscous. If you see here, slag is like aluminum silica which is present inside the iron ore. It will generate the slag. You can add some like basic oxides also to make it fluids because it requires sometimes. Plasma part and two types of plasma are there. I will discuss in details in plasma. One is direct, one is called the transporter. Another is called the non-transporter. In case of non-transporter, the disadvantage of non-transporter is actually 65% heat utilization. But heat utilization is more in case of transporter. But transporter having another disadvantage. Like for impurities removal, it is better. There will be no slag, slightly slag, you can handle it. Otherwise, what will happen when slag generation will be very high, and slag is actually viscous in nature. Always when slag will generate, instantly it will not produce the liquid, very liquid conducting slag. It requires electrons to transfer, otherwise transporter will not work. Okay. Therefore, our project in CSIR Australia is how to treat the high GAN containing Australian ore and Indian ore in plasma smelting. It is very difficult. Free body area requirement is high. One, another is the conductivity of arc. Otherwise, arc will be disconnected. Always arc will be, if your requirement is the constant arcing, stable arc. So maintaining the stable arc is very difficult. Therefore, actually you can see here pre-reduction, and then they go for the hydrogen plasma. But pre-reduction, because if you do the pre-reduction and if you separate the metallic part into metallic part and non-metallic part, then you can effectively treat in a plasma smelting. Otherwise, what will happen? These GAN materials, for making these GAN materials also it requires some energy will consume for making that slag at high temperature.
So for your laboratory arrangement,
We have transport. But non-transport arc having a benefit like, it is like a arc flame. Arc flame means it is not required any conductivity. If you have the slag, but energy requirement will be high, electricity consumption will be high. Okay. Like where does all the hydrogen comes from? We are talking about only the green hydrogen. So we are seeing first one, green hydrogen means we have the renewable source of energy we can take, and this is why we will produce that. It requires 250 million tons of hydrogen.
World.
So it is very difficult to generate. Number two, coal having benefit like Australian coal, you export, you transport it to the vessels, and it will utilize.
So these 250 million ton of hydrogen for what?
For producing the green steel, if you
Is that at present capacity?
at present capacity, if you obsolete all blast furnaces.
And replace with them.
This hydrogen, how it will create the problem? Like in every places it requires hydrogen generation because transportation is a very difficult one, and transportation hydrogen is lighter one. Therefore, volume requirement is high. To transport in a lower volume, it requires compression. how much energy is required to compress the hydrogen so that you can liquefy and transport. That cost you cannot, it will add more cost. Therefore, if hydrogen based production steel making is required, you have to generate hydrogen in-house. Like you have in-house oxygen plant or such type in-house coke making plant, such type. Similar type of in-house seal plant. This type of in-house plant is required so that you can handle issues for hydrogen. Producing 1 kg of hydrogen which has a specific energy 143 megajoule per kg requires, because I think most of that told this one. Water splitting by polymer electrolyte can electrolyzer or alkaline electrolyzer efficiency is 73%. And for making it good, because it requires -2 centigrade also, it adds cost more and it costs 35%. It means in liquid hydrogen transport is inefficient because added cost. Okay, because more 30% cost means the hydrogen cost will also increase 30% more. Then, if you see the ammonia, why ammonia? You can see the hydrogen. Okay, hydrogen density if you see kg per meter cube, lightweight hydrogen. Pressure, compressor 350 bar, compressor 700 bar, liquid hydrogen, liquid organic hydrocarbons, and liquid ammonia. You can see ammonia having density wise it is high. Okay, it means that if the density is high, then the capacity requirement, container volume requirement is small. Here if you see cost of hydrogen production cost. This is the conversion cost, and this is the import-export. This is the transmission and distribution. If you see hydrogen and ammonia, the production cost if constant. If you see here the conversion, import-export is huge amount. Okay. And if you see here, relative energy density, the compressed hydrogen having lowest. Energy density is another factor. If the energy density is high, then okay, you can less requirement of the container. If you compare the tank size, so relative volume per unit of this gas level, like hydrogen it is 2.5 liters. If you compare with the LNG, ammonia 1.9. Okay, so ammonia having slightly lower requirement of the volume tank volume. Then this ammonia to hydrogen production, actually ammonia, it will also reduce the Fe2 to Fe. But directly ammonia reaction with the Fe2, it occurs in different stages. Like when reduced iron is there, iron will act as the catalyst and it will dissociate the ammonia initially to make the hydrogen. Then this hydrogen will react the Fe2 form the Fe, and then this freshly reduced Fe will again act as the catalyst. Again it will accelerate the process of the reaction. This is the global ammonia production forecast. So you can see world total is 2048. How this ammonia production will increase. This is how this reaction generates ammonia. When it comes into the freshly reduced iron, it will generate the nitrogen gas and hydrogen. Okay. Then this hydrogen is actually reacts to the Fe2, and if you will produce freshly reduced iron, again ammonia will be cut reduction with ammonia and reduction with hydrogen. This is the two parts here. This same part is similar condition. This is the percentage degree of reduction with the time. The degree of reduction actually how we calculate it generally this is the experimental data. How we calculate this degree of reduction? Generally we calculate with the weight loss method. Okay. You can see a times for continuous in this fraction of time you cannot take out the sample and you cannot measure the percentage. Therefore, this is a continuous process. Generally, the thermogravity analyzer is used to determine the weight loss with the time, and this weight loss is converted to the reduction. Some formula is there. You can convert it, and you can determine how much percentage of reduction is there. You can see both cases. You can see with increasing the time, degree of reduction is increasing. Sometimes it is overlap, sometimes it is, but you can ignore this one. But the important thing is like this point. This point. Here you can see almost 90%, 95% reduction is completed. And in case of hydrogen, you can see it is slightly decreased, but it is almost same. But in case of ammonia reduction, if you see drastically reduction percentage is decreased. Is this reduction percentage decreased? No, sir.
Reversal of
No, reverse.
Complete reduction.
As we are measuring the reduction percentage from the weight loss, it means continuously weight loss is going on and suddenly weight gain is going on.
NS3 again found. NS3 again found after the reaction.
Technology again found.
NS3.
nitrogen enter.
But NH3 how this is the weight loss of iron ore. Suppose you put some pellets, iron ore pellets having 10 grams. Okay. Then 10 grams with time 10 grams it will be 9.9, 9.8, 9.7, 9.4, in this way it will go. Suddenly you can see the weight gain. Therefore it is decreasing. Weight gain it is decreasing. So why it gains the weight?
Maybe due to production of water molecules and that will
In
react
both
with the iron.
cases it will produce.
It will react with the iron to form iron oxide again.
In both cases, iron vapor, water vapor will produce. Number one, number two, water vapor it will come out from the system. There is some mechanism you can take out the water vapor also. So, any other?
Maybe
Every
surface
dose
integration.
Reversal.
Nitrogen entering into the iron. Nitrogen entering into the iron.
Yes. It is called nitriding. Nitriding is a surface hardening phenomena.
Yes.
What happens? If you pull down the temperature, you can see here the temperature graph is also there. This is the temperature, continuous level increase temperature, and when you decreasing the temperature, then only this weight gain is also. It means when the ammonia will go, freshly reduced iron is there at a catalyst, it will dissociate to form ammonia, a nitrogen as well as hydrogen. Until up to the, you can see that at high temperature, up to this temperature, there is no weight gain. But when you stop it, what will happen? The temperature will decrease. You can see the temperature is decreased. When it achieves certain temperature, what will happen? Nitriding will take place. Nitriding is the nitrogen. It will, as interstitial elements, it will present in the, it will go inside the iron lattice. Then it is called the surface hardening treatment, like nitriding is called surface hardening, like carbonizing is called surface hardening. So surface layer it will be nitride. The nitrate formation will be there. The famous research by Gabbe you can see the beauty like this is the what kind of sleep we get from ammonia based iron reaction. When we prepare the DRI with ammonia, if you see the microstructure, the steel quality is the nitride deposition of the steel. Then tell me, this nitride deposition, nitrogen deposition, you can see the nitrogen in the steel, uniformly almost distributed. Okay. Then, is there any advantage or disadvantage of this nitrogen absorption? If there are any disadvantage, then ammonia based reduction will be having some disadvantage. If it is having some advantage, then obviously this route will be advantageous one as compared to the hydrogen. Initially it is advantageous in this sense, like ammonia is less explosive as compared to the hydrogen. It can be handled, transportable. These are the benefits. But if it creates the reduction, problem in reduction, then you have to think another one. Is there any problem like if nitrogen absorption will be there in the metal?
Become very brittle and very light.
Or this nitrogen will give you some advantage or disadvantage?
Osmate stabilizer, but at the same time you have gas issue. EAF.
Sir, we are talking about the DRI only. We are not going into the steel itself. It is DRI. Maybe DRI contains gang materials, SiO2, all. Suppose it is 100% pure activity. Then what will happen? Iron will be pure iron, but it will be the surface will be nitride, and depth of penetration, if you see nitrogen having a smaller particles, it can diffuse in. Then, if the nitride formation is there, it acts as a insulator light. Means it will effectively coat the surface. What is the benefit? If the surface is nitride, then if you keep it in normal atmosphere, what will happen? It will not revert back to oxides. But if you reduce the iron by hydrogen, and if you keep at normal atmosphere, it will be oxidized. Therefore, nitrogen having the advantage.
So you can store DRI in method.
If we can store. But then people ask me, then what will happen if the nitrogen content in the steel will increase? Because initially they will thought that this is a steel structure. Actually no, this is the iron structure. But it will produce the steel. But this is the DRI, direct reduced iron. To make steel, it requires melting. When you do melting, another experiment they have done. They melted it. Okay. They produce steel. One from DRI produced by hydrogen, one from DRI produced by ammonia. They observe the dissolution, extra dissolved nitrogen, when it will go for the liquid phase, it will come out. Because it depends upon how much nitrogen will absorb, it depends upon the concentration of the nitrogen. Then it will come out. Okay. It depends, and another for degassing we have facilities now. Then from that treatment, it can easily take out the dissolved nitrogen. There will be no problem. Okay. It will be beneficial for stainless steel. Okay. How? Because stainless steel making, if you see conventional 88 stainless steel, chromium and 8% nickel. Then this 8% nickel, as India do not have some nickel deposit, so we prefer alternative stainless steel making by nitrogen. That's it. My group has done a lot of work fabricating this stainless steel by plasma. So in stainless steel making, if you introduce nitrogen, what will happen? You will replace the nickel, means nickel requirement will be less. At that time, you have to add some manganese. Okay. So it means the nitrogen carrying stainless steel production, if you want to do, then this DRI, it will be beneficial. But you have to think how much nitrogen can absorb. There will be some limitation depending on the percentage. 4,000 ppm, generally 4,000 ppm maximum nitrogen can achieve. And some other parameters are also there. You can introduce more amount of nitrogen there. One of the parameters is the plasma. Because if you plasma means not hydrogen plasma, plasma, nitrogen plasma. What will happen with nitrogen plasma? If, as the nitrogen plasma having also the nitrogen gas, ions, gases, it will effectively dissolve more amount of nitrogen, which is dissolved in normal nitrogen gas. Then in that way, if you think this type of iron it will be beneficial. Okay. And that there are important details, there will be no problem of chemical composition of the stick produced from the DRI, which is reduced by hydrogen, or DRI which is reduced by
This experiment was done under argon.
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 Then the challenges of ammonia reduction. If you see the mechanism, reduction kinetic, morphological processes, transport processes, and product composition and function of still now it is under research. Actual mechanism, how it is happening, it is still now it is working. One group, Rabe, Professor Rabe is the famous one, Max Planck University, is the famous one in this area. And he first time identified this problem. Why? Their group is working. One of my students is working under him. So, and the technical problem is like materials handling, reactor configuration, thermal effect, and heat integration. This problem studied further. And engineering challenges is like optimizing the operation condition, heat management, and system design, reactor models. What? This is your SAP. Okay. Normal SAP, suppose in case of they are using natural gas. So, in case of natural gas, the reduction as the water vapor is a problem. So, external energy source, how you will introduce so that this reaction will be proceed. This is one. Like I will show you some designs. IIT Hyderabad there. These are some design. The heating from both sides. Both sides means at the core there will be less heating done. At the surface there will be more heating done. If heating system is from outside. Suppose your heating system is from inside. Opposite problem will be there. Like nearby the center core will be the more heating done, and outer side it will be the less heating. What happens when this temperature variation is done? If you see the reduction with the hydrogen, the temperature range is a factor. Diagram. I can show you. If you change the temperature and obviously the H2O pressure, partial pressure of H2 or H2O, then it will change the total mechanism or reaction mechanism, kinetics of the reaction. Therefore, it is a challenge how to heat throughout the bed in the is a question. It means normal shaft reactor, if you charge the iron ore and if you inject the hydrogen, it will not reduce as per your requirement when how much reduction